Hi, my name is Nicholas Espinal. This is the 8th question from my Chapter 27 quiz, and this is what it asks. A wire segment 1.2 meters long carries a current I, which is 3.5 amps, and is oriented as shown in the figure. The positive x-axis points directly into the page. A uniform magnetic field of magnitude 0.5 teslas pointing toward the negative x direction is present as shown. What is the magnetic force vector of the wire segment? So we know that the magnetic force is current times the length vector and as the cross product with the magnetic field. And we know that the current is 3.5 amps, the length is 1.2 meters, and the magnetic field is 0.5 teslas. As a vector, the length vector has coordinates of 0i minus 1.2 sine 30j minus 1.2 cosine 30k. And thus the current multiplied by this vector is just 3.5 times that vector coordinate, and that's going to be equal to 0i minus 2.1j minus 3.64k. And the units are now going to be amp meters. And since B is pointing out of the page and it's in the negative x-axis, the vector coordinate for B is going to be negative 0.5i plus 0j plus 0k. In the unit of teslas. And so we know that the magnetic force is the cross product of the current and the length vector with the magnetic field. So we just got these vectors. So now we're going to do the actual cross product, inputting the first vector in the second row and the last vector in the last row. And we do the math here. We input the values, do the cross products for each coordinate I, j, and k. And we're going to find that the force is 0i plus 1.82j minus 1.05k. Bringing it down to two significant figures is going to be 0i plus 1.8j minus 1.1k. And we look at our answers and we compare it to ours, and we notice that the answer is C. See that it provides us with 1.8j minus 1.1k, and that's what we found. Thank you.